Hello, everyone. This is João Barros, and I'm very, very pleased to be here today with IoT with the best. I'm the founder and CEO of Veniam. And let me share my screen. I'll open the presentation just now. And here we go. And hopefully you can see the screen now. All right, and today I'll talk to you about future mobility and how mesh-connected vehicles are going to revolutionize what I believe is the smart city of the future. And so, very briefly, imagine a city where every car, every bus, every van is not only driving itself, but actually also connected to each other and to the internet, providing a whole new kind of wireless infrastructure that connects the physical world to the cloud. In Porto, the cars and vans and trucks do not drive themselves yet, but they are connected to each other in the world's largest mesh network of connected vehicles. And what this network is doing for the city, it's besides improving the transportation system, it's offering free internet access to about 400,000 people today, and also gathering huge amounts of data for all sorts of different smart city applications. Now, why do we believe that every single vehicle should be connected to each other and to the internet? Well, for one, connected vehicles are the ideal Wi-Fi hotspots. If you think about it, they're everywhere. They have large batteries, and they also have dedicated wireless spectrum. So in the United States, in Europe, and in various countries around the world, the 5.9 gigahertz band is reserved for intelligent transportation systems and so far underutilized. And Veniam, in fact, is the first company in the world to offer a commercial service on top of this frequency band. Number two is that vehicles can work as an urban scanner to gather massive amounts of data. They already come with dozens of sensors, and once they become Wi-Fi hotspots, you can actually connect any device to it, transforming the vehicles into mini weather stations, into signal detectors, be able to count people and be able to know where people are coming from, where they're going to. Obviously, always protecting their data and their own identity. The third aspect is that the vehicles can actually work as couriers for other IoT devices. So if you think about, smart traffic lights, smart trash bins that are able to tell if they're full or not, the vehicles can just go around, pick up this data and send it to the cloud through the mesh. And we're already doing several of these things in Porto, Portugal. In case of catastrophe, or if something bad happens, the vehicles actually can continue to stay connected and mesh with each other. And so while even the power grid may fall down, since the vehicles had batteries, they can continue to operate and basically save people. And so lots and lots of applications. Last but not least, the ability to save lives on the road by having vehicles detect each other and warn each other in case of hazard, and also to avoid collisions. Now, this is largely the only application in vehicle-to-vehicle that governments have been pushing heavily on, but we believe that once you actually enable the vehicles to talk to each other and become real IoT devices, that's when all of the other benefits will appear as well. And there are strong business models and economic incentives to actually do that already today with the technology that we are now able to provide. So what does our company Veniam do? So we move massive amounts of data between vehicles and the cloud. We are doing that both for vehicles that are on the road today. We're in the process also of beginning to port our technology now to new vehicles, and now have one of the largest car manufacturers as our client. And thirdly, we're preparing the networking platform for future mobility based on fleets of autonomous vehicles. Now, why do we care about massive data? Well, for one, people want to be connected, and in the future, when the cars drive themselves, people will be consuming even more internet traffic. Secondly, we need to know as much as we can about the vehicles for predictive maintenance, for managing the fleet and providing the best mobility service possible. But on top of that, also for insurance purposes and all sorts of legal requirements. The third aspect is more and more vehicles have cameras now to increase security and safety, but also to gather all the data for the kind of high-definition maps that future mobility services will require. And last but not least, we believe the vehicles can provide a lot of high-resolution data that fixed sensors, so sensors that at fixed locations are unable to provide. And that's also how we see the future with autonomous vehicle, is that the vehicles are going to be a lot more than just machines that carry people from one point to the other. They're going to be part of the city infrastructure, pretty much like elevators are part of buildings. And why can't we just put a SIM card and just connect them to the cellular network? Well, coverage is not perfect. It's extremely expensive, and the network is more and more congested. And so we see these vehicle mesh networks as an instance of, device-to-device connectivity, which is one of the features of 5G. And so Veniam's vehicle mesh networks are actually a step towards 5G, as we will see later. Now, let me show you quickly how we're learning in today's cities to deliver the platform for the future. In Porto, as I mentioned, we connected buses, garbage collection trucks, different kinds of vehicles to offer free internet access to hundreds of thousands of people and gather large amounts of data. In Singapore, we started with the shuttles of the National University of Singapore, but we're also now connecting two other clients, including the Land Transportation Authorities, buses in one of the lines, and also at the airport. And finally, as a third example, in New York, we connected the Downtown Alliance shuttles, which are these red buses you see here, which also have screens where we basically put content on top. And so we're able to get data from the vehicles, but also able to push data, and that can be supported, for example, by advertising. Now, how do the vehicles actually connect to each other? Well, we put in each of the vehicles device with multiple different interfaces. So that includes 4G and Wi-Fi, but also DSRC, which is the standard for vehicle-to-vehicle communication. This can also be LTE. It can also be another standard such as 5G. So we're quite agnostic to the physical layer because the problem we solve is the intelligent networking on top. And so that means the vehicle has to decide where to connect to, how to send packets, and share them under the vehicles and with the cloud. Now, an important piece is also deciding which data can be stored and which data needs to be sent immediately. And so that local data management is critical for us to be able to make the most out of all of the wireless interfaces that are available. And so that's already happening, as I mentioned, in Porto, New York, and Singapore, and bringing more and more vehicles and networks to the grid. And so the platform is designed to be multi-network, multi-purpose, and upgradable. If you think about it, there are many connected vehicle solutions today, but they all have the same problems. They are, number one, single purpose. So you have a little gadget to track the vehicle, a little gadget for tolling, a little gadget for getting data from the onboard diagnostics, and so on. And the fleet managers actually don't like to have so many devices they need to follow. The second problem is that they all use cellular, in many cases even just GPRS, and they're always trying to save costs. So they reduce the numbers of bits that they send from each vehicle. But with a small number of bits, there's not so much analytics that you can do. And the third aspect is that these solutions typically don't evolve. And so every time you want to upgrade the system, you need to add new gadgets. And so we designed the platform to be actually multi-network, multi-purpose, and upgradable, and to be able to do these local data management and the mesh networking and do all of that with very, very low latency. And so this builds now on our patent, which actually by now has about 100 patents submitted and 24 accepted in partnership with various universities. Now, how does this work in practice? So in practice, this is a slide for New York City, where basically, as many of you will know, they're deploying kiosks that have advertising and offer free Wi-Fi. Many cities are doing that, and you basically get a coverage more or less like this. And so it's the standard Wi-Fi range of 50 meters. And it works well when essentially you are able to be there with a smartphone, just standing close by. For the vehicles, as soon as they're able to connect, they are already out of range again. Now, with V2X technology, you get up to 10 times the range of normal Wi-Fi. And on top of that, when one vehicle connects to the access point, it becomes an access point for other vehicles as well. And so the second vehicle connects to the first one, and then suddenly, you're able to greatly expand the range even of that one access point by means of multi-hop communications. And each vehicle is still a Wi-Fi hotspot in the normal 2.4 gigahertz or 5 gigahertz. And so you get up to 10 times longer range than classical Wi-Fi, much faster connection setup. So in milliseconds, we have very low latency. Median latency is about 5 milliseconds in connection. It is overall 12 times cheaper than cellular, at an offload of about 50% of the traffic. So 50% of the traffic going from cellular now to the fiber, via GSRC V2X. We're actually in Porto already achieving 70% in the downtown area, where we have about 8 access points per square kilometers. So there are already a few questions coming in. The first question is, can you tell more about what you have in Michigan? So in Michigan, we just started deploying at the University of Michigan campus, and also at M City, where we already have some access points and also some vans now that are using our service. And I'll talk about the applications pretty soon. That was another question. I'll go through the presentation and then answer the rest of the questions all at the end. Now, let me show you one more quick video. And this was actually our first vehicle mesh network and was in Porto. And what you see, the large access points are, large dots are access points. And the little dots are trucks that carry containers. And green are vehicle-to-vehicle connections, and blue are vehicle-to interface connections, so V2V, V2I. And you see the problem is that containers block the signals, and so the mesh overcomes that. Now they're having lunch, so usually I have to wait until 1 p.m. to continue the presentation. And here we go again. And now you see, basically that the vehicles here actually follow the corridors between the containers. We also connect boats and patrol vessels. So this was already 4 years ago. So hard to believe how fast time goes. And so the advantage of ports and container terminals for this kind of IoT deployment is that they have a confined space where they have fiber and infrastructure. They have very specific goals, which is to bring the ships as fast as possible and let them go as fast as possible, which means that anything that slows down loading and unloading the ships is a problem. And so by having the vehicles share real-time information, you're actually able to provide them with all the information they need to avoid traffic congestion, avoid accidents, have better synchronization between all the different mobile assets and mobile workers. So how does this work from a technology point of view? Is basically that they have, you have to have on one hand a hardware component, which we now have a large partner for. And then we are very, very focused as a software company on the intelligent networking piece and the cloud. And so on the one hand, we have connection control algorithms that allow the vehicle to decide, do I connect to this access point, do I connect to this vehicle, do I go back to cellular? We have the mobility control protocols that allow you to have perfect handovers across all these different technologies. And so today you can enter a bus in Porto or a shuttle in Singapore. You can start a Skype call or a YouTube video, and even though the bus or shuttle is switching between all these different technologies, your connection never breaks down. We have delay tolerant protocols, basically making all the local decisions, having the vehicles share with each other data that can be in the cloud maybe in 6 hours or 12 hours and doesn't have to be sent immediately. The mesh networking piece that I showed before, of how the vehicles use multi-hop communication to send data between each other and then ultimately to the internet. And then cyber physical security, to be able to protect not just the data and the users, but actually the protocols themselves and all those systems. All of this is orchestrated from the cloud. And we also have a data analytics engine, but most of all, we provide APIs for others to build applications on top of all the data. This can be telematics applications, this can be video processing, this can be all sorts of smart cities to detect potholes and infrastructure issues, to be able to know origin destination matrices of passengers, how many passengers are coming in, how many passengers are going out, and how many of them are in the bus, things like that. So in Porto, as I mentioned, more than 600 vehicles, about 400,000 users, millions and millions of internet sessions. We're now way above that, actually. And a very strong offload. As you can see, 70% of the traffic is going through the mesh already in downtown Porto. Now, in Singapore, again, we started with National University of Singapore, and actually the usage was 26 times higher than in Porto. Once I even saw people with two smartphones, one for surfing the internet or messaging in Facebook, and the other one for hunting Pokemon. So that's how high the traffic was. And we have our network operations center where we're basically able to see where all the vehicles are and the access points, and we're able to zoom in and provide a bird's eye view of everything that is going on in the mesh. And we can even go back in time and see, how was the network performing just a little bit before, and getting all of that data in as well. We're able to zoom in and figure out, what are the different elements doing. We can introduce a specific place. Here, for example, is the bus depot. This is an ideal place for the vehicles to mesh and actually send a lot of data, video, and vehicle data up. And when you then switch on the smart city interface, you're able to see, for example, traffic through the speeds of all the vehicles. You're able to see usage of the Wi-Fi network or quality of the cellular network. Or even for a specific vehicle, you can indicate a period in time and then zoom in and basically see very carefully, what were the different parameters you got. And many of them are useful not just for the vehicles, but actually for the city, like the temperature or the air pressure, basically turning the vehicles as meeting weather stations. Now, once you're able to detect all the wireless signatures of different devices, you can actually compute where people are coming from and where people are going to. And so what you see here are the origin destinations in Porto. Now it's 6 a.m. and you start seeing people coming from the suburbs to downtown. So the black in the circle is origin and gray is destination. So you see the destination now is primarily the center of the city. And then in the afternoon, as people stop working and they start going on their commutes back home, you basically now have a lot more traffic going back as well. And there you go, people going home. In Lower Manhattan, here you see the activities. In the morning, the buses come down, and you see the Wi-Fi activities where it's concentrated around Wall Street down there. Lots and lots of activity going back and forth. And so basically the vehicles acting as mobile sensors can get tons and tons of relevant data. The other thing we did in an experiment with the University of Porto and the University of Aveiro was actually to combine our onboard devices with IoT devices that drivers can wear. This is a t-shirt by a company called BioDevices that gives you the electrocardiogram in a non-intrusive way. And so we can measure the stress of the driver through the signals from the vehicle, but also through the signals from the body of the driver. And so green means he's relaxed, and red means that he's stressed out. And you can use this to train the drivers by, at the end of a route, basically going back and then looking at the entire route, and you can check where are the red spots. And there's a red spot here, right at the bridge, so you can ask what happens. So, someone overturned me from the right and I had to brake. So we can switch to 3D, and the height gives you basically the speed of the vehicle. And so you see, indeed, the vehicle had to brake, and after the incident, the heart rate was at 109 and 81 square kilometers per hour speed. And before that, you had 88 and about 100 kilometers per hour speed. So although he was speeding, he was actually not that nervous. But once you have these stress levels from many, many drivers, you see that certain parts of the city cause stress. And so you have a danger map of the city, or at least a perceived danger map. And that provides the city then with real data to be able to add a sign or change some kind of road regulation. Now, in the future, we won't have to worry about driver stress because vehicles will be driving themselves. And so we believe that mobility is going to be provided as a service by fleets of autonomous vehicles. And then the experience of transportation is going to be a lot more like air travel, where today I enter a plane, I want to arrive on time, I want to arrive safely, I want to have a great seat and a great entertainment system, and I want to be connected all the time. I don't care if it's Airbus or Boeing. I don't care how the airplane looks from the outside. All I want is this experience. And so mobility providers are going to have to provide this kind of experiences, and moreover, they will they will actually own the fleets. For the auto OEMs, this means that they'll be selling hundreds of thousands of vehicles, no longer to consumers, but actually to mobility service providers, or become mobility service providers themselves. And so it's a huge shift in the entire mobility ecosystem. Once the mobility service providers own the vehicles, they will want to maximize the utility of that vehicle, because that also generates the most revenue per vehicle. And so we believe that autonomous vehicles will be on the road all the time, and they will be a lot more than just machines that carry people and goods. And so just like a car is more than a faster horse, an autonomous vehicle is going to be a lot more than a self-driving car. It's a revolution, we believe, similar to the difference between the smartphone and the old cell phone we used to use about more than 10 years ago. And so why does the autonomous vehicle require so much data? Well, for one, they have to process tons and tons of sensor data, and they're artificial intelligence machines. There's no such thing as too much data to be learning. But they have to exchange also a lot of data, so they have to download all sorts of maps, software updates, infotainment safety data. They also have to upload road data, vehicle telemetry, security videos, passenger data. So Intel estimates this about 4 terabytes of data per day, and even if just 20% of those has to be shared with the internet, it's a lot. On top of that, people are not driving, so the internet traffic is going to be massive. And so just to give you an example, from the street in Barcelona, about 400 people, will be using about 330 megabytes per hour of internet traffic. And the vehicles today, well, they're not connected to the internet, so about only 5% of them actually send data. Most of it is just position over GPRS, so about 0. But in the future, the same people will be generating even more traffic, 1.6 gigabyte per hour, and the vehicles, orders of magnitude more. Even if it's just 10% of this or just 5% of this, it's really, really, massive compared to what we have today. And so why do we need vehicle-to-vehicle communication? So let me show you a little video of the devices. Once they connect to access points, they can upload data like this, but once they are able to connect with each other, you get this organic mesh where basically the vehicles just expand. This is real data from Porto. And so now suddenly, you're able to get a lot more data shared over there. And so in the future, we're looking at 5G, and 5G requires mobility, manageability, diversity, low latency, location and context, and network slicing, which is basically the ability to have one physical network that is used by many different entities and network owners by creating secure logical networks on top of that. So all of these features are features that are either already productized by us or in our roadmap and being rolled out and tested at scale. And so to design the networking platform for the future, we saw how much we learned going from 50 to 500 vehicles, now how much we're learning now going from 500 to 5,000 vehicles. And so as you go to 50,000, 500,000, that's when you start having all these network effects that are needed. And when you think about software updates, map updates, all of that, can actually be shared among the vehicles. So why should a vehicle get that type of content through an expensive 4G LTE link from the cloud when it can get it for free from the neighboring vehicle? And so those are the type of scaling effects we show. You can actually save 90% of the cost of software updates for cars when you do it that way. And so the future, we believe, is going to be a future where the vehicles, again, are going to be a lot more than machines that carry people and goods. They'll be part of the city infrastructure, they're part of the wireless infrastructure. If there's a football game and I need to increase the capacity at the football stadium, I can just dispatch 20 vehicles. They can go there and basically provide internet access for people. If there's a terrorist incident and law enforcement needs more visibility, I can dispatch 10 autonomous vehicles with cameras and be able to get a lot more data that way as well. And so this is the future we're preparing for, and we're excited to be able to deliver the networking platform that is able to manage all these massive data flows among vehicles in the cloud. So thanks so much for your attention. I'm on the chat and happy to answer any questions that you might have. So thank you so much. All right, first comments coming in. So Uluwatobi Yumanola, wow, great. Well, thank you so much. I really appreciate it. Sujam was asking whether the University of Michigan has got us involved in the Power USPS program that basically will enable, I guess, the shuttles to become autonomous vehicles. So we're not at liberty to discuss that right now, but that's definitely a project we're looking carefully into. And so we have until 6 p.m., so happy to answer any of the other questions that you might have. Would be really great to know who is online. So can you just ping me on the chat if you're watching this talk? So Susham said, good presentation and great life examples. So thanks so much. Appreciate it. All of the feedback is helpful. Also things that you didn't like, this way I can improve. Or questions that you have, things that I didn't explain so well. Always really grateful for any type of feedback. Thanks, Nick. So CloudZem is asking, are there any privacy issues that you foresee in having access to the cars? Yes, we take security and privacy very seriously, and it's not an easy problem. So it's something that you have to always keep in mind. So today our systems do not interact with the control of the vehicle, and so we basically just operate on the data plane. Once you have, for example, platooning of vehicles, of autonomous vehicles, or once you may actually have teleoperation, then the security requirements, go even one step further, because obviously, among the IoT devices, vehicles are probably the ones that, have the highest risks and have to be managed most carefully. On the data we collect for smart cities, there's obviously end-to-end encryption and end-to-end authentication also among the devices, among the vehicles themselves, and the security architecture is cloud supported. So we have the cloud acting, as a trusted third party to be able to establish also secure connections among the vehicles. And so right now, basically the standards for the SRC and V2X and IEEE 802.11 P and also 1609 are already defined a certain level of security, for example, for safety messages, for all sorts of data that the vehicles have to share to improve the safety of the roads. But there's a lot of additional security layers that we're currently developing to be able to protect the rest of the system. And so there are questions on how secure the transfer of data is like. Right now, on the 5.9 gigahertz band, there are very few attacks because it's a new frequency band, but we're already preparing for a time where there may actually be. We're getting a lot of security requirements also from industrial customers who actually also expect even to have the cloud piece on premise, and so that's one important aspect of that. Looking at your questions now. Interoperability challenges. Yes, right now the standard only defines how to establish a point-to-point connection between two vehicles using the SRC or 802.11p, or right now in the future also LTE-V. But basically, it doesn't tell you how to build a very secure network on top of that. And in fact, one of the things we're now debating internally, in which pieces of our architecture we want to make open source so that others can build on top of that. So the question is on the interoperability is, do we solve for optability when we connect to IoT in cities or wearables on drivers, etc., or do you use your own, the whole stack? Well, those connections to other devices right now are typically Wi-Fi or Bluetooth, and it's not like you have an IoT standard for sure for the communications. Right now, it is basically decided on a case-by-case basis, and so we don't see yet an IoT standard evolving for the smaller devices that are gathering data. It would certainly be good to have one. In the end, it's basically built on top of Wi-Fi, so 802.11 AGN. So I already mentioned the interoperability challenges with the vehicles. So at the physical layer, basically using V2X, so the SRC, which is standardized. But then on top of that, we have our own stack, and we do the entire stack, layer 2 and above, all the way to the applications. And vehicles, from different vendors, so they are expected to come out of the factory already with the SRC and V2X, and what our software enables them to do is to basically do the most out of all of the wireless interfaces they have in the vehicle. So today they have a typical OEM will think of the SRC and V2X just as a safety technology, so like a sensor for vehicles to be able to detect each other over wireless. They look at Wi-Fi to connect the devices inside of the vehicle to the car, and then they look at 4G LTE for all the other traffic. This is somewhat narrow view in that you can actually use all these wireless interfaces and the whole bandwidth to support high bandwidth applications, which is what we do. And so with our software, they can make the most out of all of the wireless interfaces that are already installed in the car. Well, Sujam says, I love your presentation and your team's overall IP and execution. Amazing. Well, thank you so much. I'm blessed with working with an outstanding team. They're not only great professionals, they're also really great people. So I feel very fortunate and thankful to be able to work with fantastic engineers, business developers, managers. It's just a real pleasure. And we're hiring. So if anyone is interested for a really great technical challenge, please do send me an email. And so my email is jbarros, so jbarros at Veniam, VENIAM.com, or just contact us through jobs@veniam.com. And so I'm also on LinkedIn. So lots of ways to connect, and always happy to connect with great people. Okay, a few minutes left. Let me know if you have any other questions. All right, and I guess we're done. So thank you so much. And I'll close the window, and please do follow up offline, and just, do send me your email. Again, jbarros, JBARROS, at veniam.com, VENIAM.com. So looking forward to hearing from all of you. All the best. Take care. Bye-bye.